Accuracy of results is always a critical concern when analyzing models with SOLIDWORKS Simulation. Typically, result accuracy is carefully balanced with study solve time, which can increase dramatically as the mesh is refined and component interactions become more complex. Though the default blended curvature-based mesher usually handles these interactions quickly and reliably with little intervention required, the standard and curvature-based solvers have a hidden option for bonded component interactions that can speed up solve time without sacrificing accuracy, and we're uncovering it in this 2-minute tech tip. To begin, I've set up a study including two components, a simple copper leg attached to a carbon steel plate, and since we're assuming that these components are bonded together, I've applied a global bonded component interaction between them. I've also applied a basic roller slider fixture and a temperature load to the assembly, which will cause the components to expand at different rates, resulting in some degree of stress at the interface. Now, when I create a mesh for this assembly, assuming I make no changes whatsoever to the mesh settings, you'll notice that the mesh elements don't line up along the interface of the components. This misalignment doesn't necessarily mean my results will be inaccurate, so long as the mesh resolution is sufficient, but I am leaving some solve time on the table here. When using standard or non-blended curvature meshes in situations like this, bonded component interactions will use bonded contact equations to produce a solution by default, which can be relatively slow, especially in more complex assemblies. To speed things up, I can use an advanced option within the component interaction, whether global or local, to force the components to share mesh elements, fusing them together and simplifying the calculations. I'll enable the option to enforce common nodes between touching boundaries and remesh the model to show this behavior, but be aware that there are a few caveats to using it. First, it only works for solid body faces which are initially touching, and it will not work for shell elements. It's also unavailable with the default blended curvature-based mesher, and tends to be more computationally intensive when meshing. Lastly, it's possible that this option will cause the mesh to fail. If this happens, there's an option in the Mesh Property Manager to remesh failed parts independently, but this will sacrifice the enforcement of common nodes. That being said, I'll enable this option and remesh the model, including the mesh control, revealing perfectly aligned mesh elements sharing nodes across the interface of the components. Running the study once again, you may notice the stress value is a bit higher than our original study, but the difference would be negligible for most applications. I should also mention that you'll want to be sure that the result plot definition is not set to average the results across the boundary for parts, as this can obfuscate the results. If you found this video helpful, do us a favor and give it a like so others can find it too, and consider subscribing for weekly CAD tips and tricks. If you'd like to learn more about the available options for creating meshes and best practices for SOLIDWORKS Simulation, consider taking a look at our Troubleshooting SOLIDWORKS Simulation course over at solidprofessor.com, where you'll find over a dozen handcrafted lessons from industry experts. Thanks for watching, and see you next time.